What if the worst-case scenario is already happening with 3I/Atlas? We are told that 3I/Atlas is natural because that's what the data suggests. But hidden beneath layers of guessing, a much darker possibility grows. What if it isn't leaving? What if the path we think is an exit is actually something else entirely? Imagine a space probe so advanced it could copy nature perfectly, hiding in plain sight as ice and dust. Imagine a civilization so careful it sends watchers instead of messengers that never show themselves. They only observe. If that's true, then 3I/Atlas is not just a rock, but a message, or worse, a test. Tonight, we will journey into the dangerous space between science and guessing, and why October 29th will reveal this comet's moment of truth. We'll compare the natural against the unnatural, the science against the fear, comfort against worry, and ask a question both simple and terrifying. Is the worst-case scenario already happening? On the night of July 1st, 2025, a routine search turned into a page from space history. The Atlas telescope in Chile, built to list the faint wanderers of our solar system, caught sight of something it was never designed to find. A tiny spot of light, barely visible from background stars, slid across the detector with just enough movement to demand attention. At first glance, it was nothing unusual. A faint object magnitude 14 moving slowly against the sky. The observatory's automatic software marked it for follow-up, part of the endless stream of asteroids and comets logged every week. But as astronomers began to map its path, the numbers stopped behaving as they should. Asteroids bound to the sun trace neat ovals. Comets stretch those ovals into dramatic curves. Even the wildest paths eventually bend back toward our star, held by gravity's invisible rope. But this one refused to be held. With each new measurement, the path unraveled further from the familiar until it became undeniable. The curve was not an oval at all, but a hyperbola, the mathematical fingerprint of something unbound. The object was not circling the sun. It was passing by, a messenger from beyond. Within hours, the realization spread through the global network of observatories. Emails, late-night calls, hurried calculations scribbled on paper. Each independent confirmation deepened the growing sense of wonder. For the third time in human history, we were witnessing the arrival of an interstellar visitor. The name came quickly. 3I/Atlas, the third interstellar object catalogued by science, its name honoring the very telescope that spotted it first. News of the discovery rippled outward. Journalists scrambled for comparisons. Oumuamua in 2017, Borisov in 2019. Strange objects that had teased us with possibilities before vanishing back into the dark. But almost immediately, there was something different about this one. Its speed, its brightness, its chemistry hinted at by early spectra. From the moment it was noticed, Atlas carried the weight of mystery heavier than its icy core. In those first days, before the headlines sharpened and guessing took hold, there was only the raw amazement of discovery, a faint dot on a screen that connected us to the vast machinery of the galaxy. Somewhere far beyond our neighborhood, around a star we may never identify, forces had flung this fragment into interstellar exile. For millions or billions of years, it had wandered unobserved, until chance brought it into alignment with a small telescope on a mountain in South America, and through that lens, into human awareness. The discovery of Atlas was not accompanied by fireworks or sirens. No sudden flash across the night sky announced its arrival. It came quietly, as most cosmic discoveries do, slipping into our data streams like a whisper. Yet within that whisper lay the opening line of a story that could stretch our imagination to the breaking point. Because every interstellar object asks the same haunting question: what else drifts between the stars? And why did this one come to us now? Confirmation came not with fanfare, but with numbers, quiet, exact, and undeniable. Over 2 nights in early July, observatories across the globe turned their instruments toward the faint intruder first glimpsed by Atlas. Each telescope added new dots to the growing map of its path, and with each dot the truth sharpened. The orbit refused to close. Gravity could not hold it. What had seemed at first like a wandering comet was now revealed as something stranger, a body moving too fast, on a line too straight to belong to our solar system. The calculations spread like a ripple through the scientific community. In data centers and control rooms, astronomers watched their models update in real time. Oval orbits collapsing into a curve that opened outward forever. The eccentricity, a single number that defines whether an orbit is bound or free, crept higher with each refinement. 1.01, then 1.1, then higher still. Anything above 1 meant escape velocity, a path never returning to the sun. By the morning of July 3rd, the verdict was unanimous. This was hyperbolic. This was interstellar. For the third time in human history, the cosmos had delivered a traveler from beyond. Oumuamua, slender and mysterious, had startled us in 2017 before vanishing with more questions than answers. 2 years later, Borisov had followed, a comet in every sense, though still a foreigner from another star. And now Atlas joined their ranks, carrying with it the promise of new knowledge and new mysteries. For the astronomers, the realization brought a mixture of excitement and unease. To detect one interstellar object had felt like luck. To detect 3 in less than a decade suggested something more. A galaxy filled with these wanderers, countless fragments of alien star systems slipping silently through the void. If 3 had already been found by chance, how many more had passed unseen? How many had crossed our skies when no telescopes were watching? The press releases tried to capture the importance, but words felt clumsy against the weight of what the data suggested. A piece of another solar system had entered ours. Its icy body had formed around a distant star billions of years ago, then flung outward by some ancient planetary encounter. It had spent ages drifting between suns, carrying within it chemical signatures of its birthplace, until at last it crossed paths with Earth's instruments and left its mark in our records. There was something deeply humbling in this confirmation. Our world had become, however briefly, a stop along a journey that had begun long before humanity existed and would continue long after we were gone. The object itself showed no awareness, no intent, only momentum, an ancient memory locked in ice and dust. Yet its presence forced us to look outward and ask harder questions. What stories do these visitors carry from the galaxy's far corners? And more unsettling still, what stories might they be writing about us as they slip past, silent witnesses to our brief flicker of civilization? At first, it was nothing more than a temporary designation, a string of numbers and letters generated by the software that tracks new space objects. C/2025 none, a cold label that placed it neatly in the list of comets and asteroids. Yet the moment its path was confirmed as interstellar, the cold catalog number no longer felt enough. Something that had crossed the gulfs between stars deserved a name that acknowledged its rarity, its strangeness, its role in human imagination. The International Astronomical Union moved quickly, following the pattern established with its predecessors. Oumuamua had been One Eye, the first interstellar object ever confirmed, its name drawn from Hawaiian for a messenger that arrives first, reaching out. 2 years later, Borisov became Two Eye, the second messenger, less poetic perhaps, but still marked by its discoverer. Now this new wanderer was given its place in the sequence, Three Eye, the third. The rest followed naturally. Atlas, the telescope whose digital eyes first caught the faint flicker on July 1st, was honored in the second half of the name. Together they became 3I/Atlas. It was a simple designation, yet the transformation was immediate. A string of numbers now carried weight, meaning, and myth. Scientists could speak of it with ease. Journalists could frame headlines around it, and the public could imagine it as something more than a data point. The name became a container for story. Language has always carried power in our relationship with the cosmos. The ancients mapped constellations into gods, hunters, lovers, and monsters, their names shaping how generations saw the night sky. Even today, a dry acronym can create awe when attached to the right discovery. To call this object Atlas was to place it in a family line of cosmic messengers, each one more than just rock and ice, each one a symbol of the galaxy's hidden connections. Already, guessing gathered around the name itself. Atlas brought to mind the Titan of Greek myth condemned to hold up the heavens, an unintentional echo that made the object feel larger than life. The third messenger became a phrase whispered in late-night forums, as if the universe itself were sending us a series of signals, one every few years, each stranger than the last. Oumuamua the first call, Borisov the second, and now Atlas, swifter and more chemically strange than either. To some, it felt like escalation. Names fix objects in memory long after their physical traces are gone. Oumuamua has long since faded from sight. Borisov broke apart into dust, and Atlas will soon vanish into the dark. Yet the names remain carved into human history, touchstones for stories that stretch from cautious science to cosmic myth-making. This latest designation, born of cataloging necessity, has already begun its change. Atlas is not merely a comet on a hyperbolic path. It is a symbol of contact with the wider galaxy, A reminder that even in silence, the universe still speaks. And perhaps most unsettling of all, once a name is spoken often enough, it begins to feel less like a discovery and more like a character in an unfolding story. Atlas is no longer just passing through. It has entered our story. The first wave of reports came quickly, as they always do when a new object enters the astronomical record. Atlas was classified, described, and placed neatly in the box marked Comet. The images revealed a faint halo of gas and dust, the telltale coma that blooms when sunlight strikes frozen ices. Its orbit, though extraordinary, was still predictable, its path carrying it safely past Earth at a comfortable distance of 270 million kilometers. The official language was calm, measured, reassuring. There was no danger here, no threat to our world, just another comet, though one born under an unfamiliar star. NASA's initial statement read almost like a sigh of relief. Yes, it was unusual. Yes, it was fast. But it was also safe. Journalists echoed the message, careful not to create unnecessary panic. Interstellar visitors, after all, had a history of stirring more imagination than needed. Oumuamua had been painted as an alien probe by some, only to slip away silently, leaving nothing behind but debates. Borisov had reassured us by behaving exactly like a comet should. Atlas seemed destined to follow that pattern, another curiosity to be studied, catalogued, and then forgotten as it disappeared back into the dark. For the public, the early impressions were easy to digest. A comet. A visitor from another star, yes, but still a comet. Something that could be understood, explained, made familiar by the language of science. The headlines leaned into wonder rather than worry. Third interstellar traveler confirmed, cosmic messenger from afar, a harmless visitor from the stars. It was a story that invited awe without demanding anxiety, an opportunity to marvel at the scale of the universe without confronting existential fear. Astronomers too found comfort in its apparent familiarity. The coma expanded as expected, responding to solar heating. The light curve, while faint, fit within known ranges. The absence of unusual radio signals reinforced the story of normalcy. Observatories in Chile, Hawaii, and Spain logged spectra that showed carbon dioxide and dust, strange in its ratio, but not impossible. For a brief moment, it seemed that Atlas would behave, playing the role of interstellar comet with textbook precision. And yet beneath the surface of these early impressions, there lingered a quiet unease. The speed was too high, far greater than its predecessors. The chemical balance was unlike anything seen in local comets. The angle of approach, tilted against the galactic plane, hinted at origins older and stranger than the sun itself. These details were tucked into the back pages of press releases and the footnotes of academic papers, acknowledged but not emphasized. To the wider world, Atlas was harmless, natural, ordinary, a comet like many before it. But to those who watched closely, who had seen how quickly ordinary can unravel into the unexplainable, the reassurance felt fragile. The first impressions were comforting, yes, but comfort has a way of dissolving once the deeper mysteries begin to surface. From the beginning, NASA understood the assignment. When the words interstellar object appear in headlines, the human imagination ignites in ways equations alone cannot extinguish. So the first official statements arrived wrapped in the language of precision, control, and calm. No threat to Earth, the press release read. Closest approach, 1.8 astronomical units, nearly twice the distance between Earth and Mars. Numbers meant to anchor us, figures meant to soothe. In carefully measured tones, officials explained what the discovery meant, and more importantly, what it did not. This was not a collision course. It was not a planet killer. It was not, despite whispers in late-night forums, an alien craft scanning our skies. Atlas was, they insisted, a natural comet from another star system, passing harmlessly through before continuing on its hyperbolic path into the interstellar night. The briefings emphasized heritage, continuity. NASA had done this before. Oumuamua had come and gone without incident. Borisov had burned bright and then faded, and Atlas would do the same. The math was reliable. The models were solid. Celestial mechanics left no room for doubt. The universe, chaotic though it may appear, still bent to the laws of physics, and those laws predicted safety. To many, the tone felt like a lullaby spoken in the language of science. Numbers whispered like reassurance. Eccentricity greater than 1, perihelion at 1.4 AU, path already mapped years into the future. There would be no surprises, no sudden turn toward Earth. It would not even come close enough to require planetary defense exercises. This is an opportunity, the officials repeated, not a hazard. And yet, the very precision of these reassurances carried an unintended edge. The confidence was absolute, but it had to be. If there were doubts, they could not be shared. The public, already ready to see danger in the unexplained, required certainty. But certainty in the face of the unknown is a delicate mask, one that can crack when details begin to emerge. The statements avoided mention of the odd chemistry, the unusually high carbon dioxide signature, so unlike anything found in local comets. They noted the extreme velocity but framed it as a curiosity, not a concern. They did not dwell on the angle of approach, steep against the galactic plane, suggesting origins in the thick disk where ancient stars still circle. These details were for the journals, not the evening news. For the casual observer, NASA's words were enough. Safety was assured, the cosmos remained under control, and humanity could go on with its daily rhythms while an alien-born comet blazed invisibly across the depths of space. But for those who listened closely, the silences spoke as loudly as the reassurances. Numbers may banish fear, but they cannot silence the questions that lurk just beyond the reach of certainty. Was it truly harmless? Or was the worst case not about impact at all, but about what we might learn, and what we might never be able to unlearn? Speed has always been the quiet tell in astronomy. The way an object moves tells you not only where it's going, but where it has been, what forces have touched it, and what history lies carved into its path. With Atlas, the numbers spoke louder than any photograph. 61 km/s, more than 130,000 mph, a velocity that dwarfed its predecessors, nearly doubling the pace of Oumuamua and leaving Borisov trailing behind like a slow caravan in comparison. At first, this fact was packaged neatly as another curiosity. Yes, it was fast. Yes, faster than expected. But interstellar space is vast and violent, and objects flung from their birth systems carry scars in the form of momentum. Still, the deeper the models ran, the more uneasy the data became. The simulations didn't add up. The object hadn't just wandered here. It had raced, and not in a way that current models fully explained. Planetary ejections, gravitational slingshots, encounters with giant worlds in early star systems. These processes can speed up debris, yes, but there are limits. Energy budgets in astrophysics are not infinite. To see an object moving at this speed suggested something more than the ordinary chaos of planet formation. Some guessed it had passed close to multiple stars in its long history, stacking accelerations across ages like compound interest. Others wondered if the velocity pointed to an origin not in the familiar thin disk of our galaxy, but in the ancient thick disk where stellar movements were harsher, or even beyond, in regions of the Milky Way we barely understand. And yet in the quiet corners of discussion there were other questions, the kind not raised in official press briefings. Was the speed random, or was it telling? Could acceleration of this kind ever be mistaken for something else? Something deliberate? When Oumuamua passed through, Harvard astronomer Avi Loeb famously suggested it might be a light sail pushed by starlight across the gulfs. That idea had been dismissed by most, filed away as provocative guessing. But here was another interstellar object moving even faster, and once again the model strained at the edges of believability. NASA's official line remained firm. Natural explanations sufficed. Multiple gravitational encounters over billions of years could account for the velocity. The laws of physics held, even at 61 km/s, but in the subtext, in the uneasy glances of researchers when cameras weren't rolling, lay the awareness that speed, unlike shape or chemistry, leaves little room for interpretation. Something had driven this ancient wanderer to a pace that few had expected, and it was already here, cutting through our solar system with the precision of a cosmic blade. The problem with speed is not just what it reveals about the past, it's what it means for the future. At such velocity, Atlas cannot be captured by our sun. It will not linger. It will pass through, reveal itself only briefly, and vanish forever. And in that fleeting encounter, humanity must decide whether what it sees is simply another comet, or a messenger carrying truths we are not yet ready to face. When the James Webb Space Telescope turned its mirrors toward Atlas, astronomers expected improvement, not revelation. Spectroscopy has a way of cutting through uncertainty, breaking light into molecular signatures that tell stories of composition, temperature, and history. But the story that came back was not the one anyone expected. The readings showed a coma dominated not by water vapor, the bread and butter of ordinary comets, but by carbon dioxide. Not just elevated levels, but an 8. One ratio so extreme it rewrote every assumption about what a cometary body should be. On Earth, carbon dioxide is a familiar ghost. We exhale it, we fear it, we control it. In comets, it plays a role, but always secondary, always less important than water. Water evaporates easily in the warmth of sunlight, creating the glowing halos that mark comets across the sky. C-Otwo, by contrast, is usually the supporting actor, appearing in smaller amounts, detectable but never dominant. Until now, the data from Webb was met first with disbelief, then with silence, then with the kind of careful rechecking that betrays quiet unease. Could the instruments be wrong? Was calibration off? Repeated measurements dismissed those hopes. The ratio held. Atlas was breathing carbon dioxide in volumes that made no sense, not for something drifting through interstellar space for billions of years. Theories rushed in to fill the gap. Perhaps the comet had formed near its parent star's C-Otwo snow line, where temperatures favored carbon dioxide over water ice. Or maybe cosmic rays had processed its surface across geological ages, sealing water beneath a crust while allowing C-Otwo to escape. Another possibility was the presence of an insulating dust blanket that protected water ice while letting carbon dioxide bubble outward. Each explanation was believable, elegant in its own way, but none felt entirely satisfying. The strangeness wasn't just the chemistry, but the timing. At over 3 astronomical units from the Sun, where most comets remain quiet and inactive, Atlas was already active, already shedding gases in defiance of expectation. It was as though it couldn't wait, as if some deeper mechanism was stirring it awake long before the usual signals. Publicly, NASA described the chemistry as unusual but informative. A valuable clue to planet formation in other star systems, they said. A rare chance to glimpse alien conditions preserved in ice. But privately, some scientists wondered if the oddity carried implications beyond simple origin stories. Why this much carbon dioxide? Why this early activity? Why now? The human mind, ever hungry for meaning, drifted toward more unsettling interpretations. What if the chemistry wasn't just a leftover of ancient formation, but something designed, something engineered? What if the ratios weren't random, but deliberate signatures rather than substances? The thought was quickly dismissed in official circles, but it lingered like static at the edge of reception. In the end, the chemistry puzzle left more questions than answers. Atlas was no longer just fast, no longer just strange in its path. It was chemically alien in a way no comet had ever been. And as it continued inward toward the Sun, astronomers knew the puzzle was only beginning to unfold. Silence in the cosmos is never just silence. Every star hums, every planet radiates, every comet whispers in static bursts of natural noise. Space, contrary to imagination, is not quiet at all. It is filled with the chatter of physics. That is why when radio telescopes turned toward Atlas, astronomers expected something, anything, however faint. The evaporation of gases, the interaction of charged particles with solar wind, the natural hiss of a comet alive under starlight. There should have been the familiar background chorus. Instead, what they heard was nothing remarkable. No narrowband signals, no modulated transmissions, no patterns that might suggest intelligence. Just the bland murmur of a comet doing what comets do. Officially, this was confirmation of normalcy. No alien beacon, no interstellar broadcast, no technological oddity hiding in the static. In fact, the silence became another reassurance folded neatly into NASA's story. Atlas was natural, and radio silence proved it. But for those who dwell in guessing, silence is not the absence of signal. It can be the signal. The dark forest hypothesis has haunted SETI for years. The idea that advanced civilizations might choose to remain hidden, stopping transmissions to avoid detection by predators in the galactic night. In such a cosmos, silence becomes strategy. The absence of communication is not emptiness. It is survival. If Atlas were a machine or a messenger, what better disguise than silence? A comet that behaves like a comet, emitting nothing more than the hiss of gas and dust, would slip past every watchful ear. And yet, silence is a tricky thing to interpret. Was it deliberate, or was it simply the way of nature? The telescope scanning Atlas reported nothing more exotic than broad-spectrum noise. But that result also matched the simplest camouflage. If an advanced probe wished to pass unnoticed, it would copy the randomness of natural emissions so perfectly that even the most sensitive instruments could not tell the difference. The question then becomes one of intent. If silence is chosen, it suggests awareness of us of detection of the risks of being known. But if silence is forced, a byproduct of design so subtle it hides even from our fear, then perhaps the signal we seek is not in what we hear, but in what we don't. The scientists did their due diligence. Dozens of radio arrays across the world listened, Arecibo's successors, the vast dishes of the Deep Space Network, even amateur SETI projects hungry for discovery. The verdict was unanimous. Atlas was quiet. Quiet in the way space debris is quiet, in the way ancient ice drifting between stars is quiet. And still a discomfort lingered, because silence in this case was louder than noise. It was definitive. It was as if the object had passed an audition for being unremarkable and had done so flawlessly. Too flawlessly. If something wanted to remain hidden, what better mask could it wear than the silence we have already convinced ourselves to expect? Paths tell stories long before chemistry or imagery can. The path of an interstellar object is not random. It is the fossil record of gravity itself, shaped by encounters stretching back across billions of years. When astronomers traced the orbit of Atlas, they noticed something unsettling in its geometry. Unlike most visitors to our solar system, which tend to arrive in the general flow of the galaxy's thin disk, moving with the broad rotation of stars around the Milky Way's center, this one came from an odd angle. It cut across the sky not as a fellow traveler, but as a stranger, tilted and skewed as though it belonged to an older, more chaotic population. This immediately drew comparisons to the galaxy's thick disk, that ancient stellar component populated by stars with unusual tilted orbits. The thick disk is older than the sun, older than the spiral patterns we find familiar, older even than many of the metals and elements that make up Earth. If Atlas emerged from that population, then it is not just interstellar. It is intertemporal, a survivor from an era when the Milky Way was raw and violent, when collisions between baby galaxies stirred stars into chaotic patterns, and when icy fragments like this one were flung into gulfs, they would wander for ages. The oddity of its path raised both excitement and unease. Excitement because a thick disk origin meant Atlas could carry chemical records of a galaxy we no longer live in. Unease because such an origin suggested age so extreme that it forced uncomfortable questions. Could this really be debris that had survived billions of years, longer than complex life has existed on Earth? How does something so relatively fragile endure cosmic ray bombardment, interstellar dust collisions, and gravitational disruptions for geological ages without being destroyed? The orbital tilt seemed to whisper, "This is not recent, not ordinary." The simulations only deepened the mystery. Most interstellar objects traced back to believable ejection scenarios around familiar star systems. Atlas did not. Its approach angle fit no simple family line. Instead, it bore the marks of a history written in erratic encounters, perhaps even one that began outside the regions of the galaxy we usually study. It had traveled on its own schedule, ignoring the galactic currents like a relic adrift. For some, this was enough. The orbit confirmed what spectroscopy had already suggested. Atlas was an ancient messenger, older than the solar system, bearing witness to the Milky Way's early age. For others, the angle was too strange, too deliberate seeming. If an object wanted to arrive undetected, wouldn't it avoid the main highways, slipping in from directions where fewer eyes were pointed? NASA stressed the natural explanations: orbital eccentricity, galactic scattering, random chance. Yet the unusual path lingered in the imagination like a riddle, not threatening, not explainable, but undeniably odd. A curve written against the canvas of the stars, hinting that the true story of Atlas is older and stranger than any we have yet dared to tell. Every comet has its moment of truth, the instant when it draws nearest the sun and either flares with brilliance or crumbles into silence. For Atlas, that moment was marked on calendars almost as soon as its orbit was calculated. October 29, 2025. The date loomed like an astronomical deadline, a countdown not just to a physical turning point, but to an unveiling. Perihelion, the close brush with sunlight, would strip away mystery. Heat, relentless and impartial, would test whatever secrets lay frozen inside this interstellar wanderer. Telescopes worldwide were booked months in advance. Ground-based observatories would track the brightening coma as solar radiation turned ice into gas. Hubble would capture images as long as Earth's atmosphere allowed. The James Webb Space Telescope would watch with its spectrographs tuned, ready to catch whatever molecules boiled off as temperatures surged. Amateur astronomers, too, prepared for the spectacle, their smaller scopes waiting for the faint smudge to blossom into something visible against the night sky. Excitement buzzed, not because anyone expected disaster, but because perihelion is the great revealer. Will the comet brighten dramatically, spraying tails of gas and dust that paint the sky? Or will it break apart, its core splitting under the stress of heat and outgassing, leaving behind only a fading smear of debris? For an ordinary comet, both outcomes are believable. For Atlas, the stakes felt higher. Its chemistry was already strange, its path unsettling. What would happen when the sun poured its full energy onto an object that had not been warmed this way for billions of years? Some guessed the heating might unlock water ice hidden beneath the carbon dioxide crust, shifting the molecular balance and revealing deeper layers of its story. Others wondered if the unusual sea Otwo dominance would only intensify, flooding space with carbon in amounts never before seen. The most speculative, of course, whispered about activation, about dormant systems buried in ice, waiting for the signal of sunlight to awaken. If Atlas were more than a comet, perihelion would be the stage where it dropped its disguise. NASA's language remained calm, precise, steady. Perihelion would bring no danger to Earth. The object's distance, nearly 1.5 astronomical units from the sun at closest approach, kept it safely out of range of planetary disruption. But even the official press releases admitted curiosity. The chemistry was unusual, the behavior unpredictable, and the data potentially groundbreaking. As the days ticked down, it felt less like waiting for a comet and more like anticipating an arrival. Each night sky seemed to hold its breath. Astronomers sharpened their instruments. Journalists prepared headlines. Even casual sky watchers began to ask, what happens when it heats up? Because when ancient ice meets modern sunlight, something always changes. The question was not whether Atlas would reveal itself, but what exactly it would choose to reveal. And the countdown to that revelation had already begun. The comfort of a hyperbolic orbit lies in its simplicity. The math says the object comes in fast, swings around the sun, and departs just as fast, never to return. It is the cosmic equivalent of a passing stranger, curious perhaps, but gone before you know it. That was the reassurance offered when Atlas was discovered. Its eccentricity greater than 1, its velocity too high for capture, its fate written in geometry. But reassurance has a way of cracking when imagination takes hold, and a darker possibility begins to creep in. What if the flyby is not departure at all? What if it is slowing down? In orbital mechanics, speed is everything. Too much and you escape forever. Too little and you fall captive. What if Atlas carries the means, natural or otherwise, to alter its velocity at precisely the right moment, to shed just enough speed to shift from an interstellar path into something more permanent? The sun, after all, is not just a source of light. It is a brake, a well of gravity that can slow as well as fling. For spacecraft designed by human hands, slingshot moves around planets are routine. What if, for something far older and far more advanced, stars themselves serve as the ultimate engines of slowing down? Such guessing finds no evidence in the data. Every measurement of Atlas aligns perfectly with a natural hyperbolic escape, and yet the perfection itself unsettles. Objects flung from stellar nurseries should wobble slightly, betray scars of their chaotic origins. But Atlas glides with calm predictability, as though rehearsed. If one were to design a path to copy nature, would it look any different from this? The eerie thought is not that Atlas will crash into us or linger near Earth. The distances remain too vast for that. The unsettling possibility is that its path has been chosen not for escape, but for insertion, to drift into a stable orbit in the outer solar system, to vanish into the clutter of the Kuiper belt, indistinguishable from icy debris. To stay, silence would still reign. No transmissions, no sudden course corrections, nothing obvious to betray intent. Only the quiet act of slowing down, of remaining where the math insists it should not. The greatest disguise is not in hiding, but in pretending to leave and then never actually going. NASA has dismissed such notions, confident in the calculations, and perhaps rightly so. Gravity does not lie, and hyperbolas do not bend themselves. But the very act of considering the alternative forces us into an uncomfortable awareness. Our models of nature are so precise that anything wishing to imitate nature need only match them to perfection. So the question lingers, not in equations, but in imagination. What if Atlas is not a fleeting messenger at all? What if the worst-case scenario is already happening? Not a collision, not destruction, but a quiet arrival disguised as departure. Nature has always been the perfect camouflage. To hide in plain sight among the chaos of comets and asteroids requires no invisibility cloak, no exotic force fields, only imitation. For a civilization advanced enough to cross the gulfs between stars, disguising technology as ice and dust might be child's play. And Atlas, with its coma of carbon dioxide and dusty tail, offers an unsettling case study in how convincingly that disguise could work. Comets are messy, inconsistent, prone to breaking apart and sputtering as they near the sun. Their brightness flares unpredictably. Their spectra vary from one to another, sometimes rich in water, sometimes in carbon monoxide or methane. Inconsistency is their signature. So when Atlas presented astronomers with an unusual composition, carbon dioxide dominating in ways never before seen, it raised questions, but none that demanded exotic explanations. After all, comets are supposed to surprise us. That is what makes the disguise so perfect. If one wanted to mask a machine beneath layers of natural material, the logic would be simple: wrap it in ices, coat it with regolith, ensure that every outward signal matches what astronomers expect from frozen debris. When sunlight strikes, let it vent gas. When viewed through a spectrograph, ensure the ratios remain just odd enough to be chalked up to formation under unusual conditions. From the outside, nothing seems wrong. Only a whisper of strangeness lingers. The idea that alien technology could masquerade as a comet is not new. Decades of speculative thought in the search for extraterrestrial intelligence have circled this possibility. Bracewell probes, von Neumann machines, silent observers seated among the stars, all could wear the mask of a natural body. The key would be subtlety, not spectacle. Not glowing beacons or obvious structures, but chemistry tuned to blend with background noise. Atlas, if it were such a thing, would have succeeded brilliantly. Its speed, while high, matches natural expectations of an ejected interstellar body. Its path follows the clean geometry of a hyperbola. Its coma glows just as theory predicts when ices evaporate under solar heat. Every test applied to it so far has confirmed what it appears to be: a comet. And yet this very perfection unsettles. For what better way to avoid detection than to match every expectation of nature exactly? NASA insists on natural explanations, and the evidence supports them. But the silence, the odd chemistry, the flawless mimicry, all leave open a sliver of unease. If alien technology wished to hide, it would not do so in steel and circuitry, but in ice and dust. Not as something extraordinary, but as something ordinary, something we would never think to doubt. And so Atlas passes our instrument's gaze, every measurement confirming its naturalness, every confirmation deepening the irony. Perhaps the greatest deception is not in what is hidden, but in how convincingly the ordinary can conceal the extraordinary. Imagine a civilization so ancient, so patient, that reconnaissance does not arrive in gleaming craft or roaring engines, but drifts toward us disguised as the most ordinary things in the sky. Not sources, not signals, but comets. To human eyes, they are harmless wanderers, ice and dust baked into erratic tails by sunlight. To alien eyes, they could be the perfect surveillance devices, slipping unnoticed into planetary systems under the guise of natural debris. This is the unsettling premise of the surveillance hypothesis, that some interstellar objects are not accidents of gravity, but deliberate insertions. Comets, after all, are everywhere. They come from the Oort cloud, the Kuiper belt, the scattered disk. They are expected, messy, and unremarkable. When astronomers detect one on a strange path, the instinct is to catalog, not to panic. What better camouflage for a probe than the very objects our telescopes are trained to ignore? Atlas lends itself to this guessing uncomfortably well. Its hyperbolic path fits what a true interstellar visitor should follow. Its speed, while astonishing, remains within the bounds of possibility. Its coma behaves as expected when the sun's heat strikes its frozen skin. Every observation so far confirms the comet story, and yet its peculiar chemistry, carbon dioxide overwhelming water in unprecedented ratios, hints at strangeness. To most scientists, this is a puzzle of formation history. To others, it's a possible signature of design. If one wished to conceal sensors, instruments, or even dormant machines, why not wrap them in exotic ice that produces exactly the kind of oddities nature already provides? The logic behind cosmic surveillance is chilling. Launch a fleet of disguised probes, scatter them across the galaxy, and wait. Some will be destroyed, others lost, but a few will drift silently into developing systems. There, without revealing themselves, they can watch. They can listen. They can catalog the rise of civilizations like ours without ever needing to announce their presence. To us, they remain indistinguishable from comets. To them, we are an experiment observed from a distance. Of course, the evidence remains firmly on the side of the mundane. No unusual signals have been detected. No course corrections betray hidden propulsion. Every wobble in Atlas's path can be explained by the faint push of outgassing. And yet, the absence of proof is not proof of absence. A truly advanced probe would not broadcast its presence. Its very survival would depend on remaining undetectable, folded seamlessly into the background of the universe. The surveillance hypothesis, then, is less about proving alien intent and more about unsettling our assumptions. It reminds us that not every visitor need arrive in spectacle. Some might prefer silence, subtlety, and patience measured in ages. As Atlas sweeps past the sun and prepares to depart, the question lingers like a shadow behind the data. Was this merely a comet, or was it watching us all along? Astronomy has always read chemistry like a language. Each line in a spectrum is a syllable. Each ratio, a word in the story of a star, a planet, or a comet. When sunlight strikes an icy core and molecules escape into the void, they carry with them information written in wavelengths of light. For most comets, the story is familiar. Water dominates, with supporting roles for carbon monoxide, methane, ammonia. But Atlas has disrupted this familiar grammar. Its lines sing almost exclusively of carbon dioxide. Its ratios, strange, unnatural, like a sentence written in a dialect no one has ever heard before. To most scientists, the explanation is straightforward enough. Perhaps it formed farther from its parent star, beyond a C-Otwo snow line where carbon dioxide condensed in abundance. Perhaps its surface chemistry was altered over billions of years by cosmic rays, creating a crust that locks water in while allowing C-Otwo to escape. These are natural scenarios, believable and grounded in known processes. And yet, for some, the thought lingers. What if this chemical oddity is not simply an accident of formation, but a deliberate signal? Encoding information in chemistry would be a masterstroke of stealth. A probe broadcasting in radio can be detected and intercepted. A machine with visible structures can be photographed and questioned. But chemistry masquerades as nature itself. Every astronomer expects comets to be chemically diverse, to surprise us with odd ratios and unusual volatiles. To hide meaning in those ratios would be to use our own expectations against us. Imagine a civilization that thinks on time scales beyond our comprehension. It seeds the galaxy with disguised messengers, each one carrying chemical signatures tuned not just to survive ages, but to convey information when finally observed. Ratios of C-Otwo to H2O could form a code. Patterns too precise to be coincidence, yet subtle enough to be dismissed as natural variance until someone looks closer. A repeating prime sequence. A ratio matching physical constants. A pattern that whispers, "We were here." Nothing in the current data confirms this. The Webb spectra shows strong carbon dioxide, weak water, unusual but not beyond imagination. The coma behaves as physics dictates, sunlight heating volatiles until they escape into space. No prime numbers emerge. No encoded constants reveal themselves. And yet the very act of measuring raises the question. How would we know if chemistry itself carried a message? Do we even have the tools to read such a code? Or would it pass us by as noise in the background of the universe? The safest answer is that Atlas is natural, a leftover of alien geology, not alien intention. But guessing persists because the silence of space leaves room for wonder. In that silence, chemistry might be more than frozen gas. It might be the medium of a message, an alphabet written in ratios of ice and dust, waiting for us to learn how to read. There is a theory whispered in the halls of astronomy and sharpened in the pages of science fiction. A theory as chilling as the vacuum between stars. It is called the dark forest. The idea is simple, brutal, and terrifying. The universe is a forest at night, and every civilization is a hunter moving silently through the trees. To reveal yourself is to risk destruction. To remain quiet is to survive. In this view, silence is not absence. It is strategy. When Atlas glides through our solar system without a sound, it could be nothing more than a comet, a frozen leftover of another sun's nursery. Yet the stillness carries an unease. No signals, no strange emissions, no controlled moves, just the quiet glow of a coma and the predictable arc of a hyperbola. Everything fits the profile of natural behavior. But if the dark forest hypothesis is true, then silence is precisely what we should expect from intelligence advanced enough to endure across cosmic time. Imagine for a moment that Atlas is not simply a comet, but a probe. Its mission would not be to announce itself, not to beacon across the void with radio waves, not to draw attention. Its mission would be to listen, to watch, to blend into the noise of nature and record what it sees. Because in a universe where survival depends on secrecy, the most dangerous act is to speak. This turns our perspective inside out. For decades, humanity has scanned the skies, hoping to hear something, an artificial signal, a narrowband transmission, anything that would break the silence. We've sent our own messages, too, from the Pioneer plaques to the Voyager golden records, whispers into the dark in the hope that someone is listening. But if the forest is truly dark, then these acts may be less like greetings and more like flares, revealing our position to predators we cannot yet imagine. Atlas may be nothing more than ice and dust, a wanderer shaped by gravity and time. But its presence stirs the question, what if the worst-case scenario is not collision, not invasion, but observation? What if we are already cataloged, already known, our world marked in the logbooks of an intelligence that never needed to say a word? The dark forest does not promise answers. It promises tension, the kind that grows when silence itself becomes suspicious. As Atlas rounds the sun and prepares to leave, it may carry nothing but carbon dioxide and ancient memories of its birth. Yet for those who take the whisper seriously, its silence is not comforting. It is haunting. Because in the forest of stars, quiet is not peace. Quiet is the sound of someone watching. From the very beginning, astronomers were clear. Atlas poses no danger to Earth. Its hyperbolic path is exact. Its closest approach, distant by hundreds of millions of kilometers, it will never touch us. The mathematics are absolute, comforting in their certainty. Celestial mechanics does not lie. And yet, despite this reassurance, a different kind of unease has taken hold, an unease not born of physics, but of imagination. We are conditioned to fear impact. The scars of past collisions are written across our planet's surface. From the Yucatan crater that ended the age of dinosaurs to the Siberian blast of Tunguska. Hollywood has trained us further, filling screens with fiery impacts and desperate last-minute rescues. When the word comet enters headlines, the mind jumps to catastrophe. The discovery of Atlas was no exception. Before orbital models were even finalized, some asked the primal question, is it coming for us? The answer firmly is no. The numbers tell a story of safety, of a visitor that will pass by and disappear back into interstellar night. And yet the absence of physical threat has not dispelled the psychological one. Because while the equations close the door on impact, they open another, on possibility. If not collision, then what? If not destruction, then meaning. This is where the imagination stirs more deeply than gravity ever could. A rock and ice body that comes too close is terrifying in an obvious, gut-level way. But a rock and ice body that does not collide, that merely passes through, unusual, alien, unexplainable, invites guessing that feels subtler, stranger, and harder to shake. We are safe, yes, but perhaps safety is not the same as comfort. The psychological weight of Atlas lies not in the threat of extinction, but in the confrontation with the unknown. It is the third confirmed interstellar visitor, a category of objects so rare that each arrival reshapes our understanding of the galaxy. It travels faster than its predecessors, carries chemistry stranger than anything we've cataloged before, and approaches from angles that speak of origins in ancient stellar populations. These facts are not dangerous in the physical sense, but they tug at something older in the human mind, the unease that comes when we realize how little we understand, how much may remain hidden in the dark. So the collision never comes. Earth spins on untouched. Life continues beneath skies that will never flare with the fire of an incoming impact. But in that very safety emerges a subtler disturbance. If Atlas is not here to kill us, then why is it here at all? The psychological threat is not the fear of dying, but the fear of being observed, of being studied, of being confronted by a reality stranger than anything we imagined. We are safe, but uneasy, protected, but not reassured. The danger is not in the math, but in the silence. If the models are right, Atlas may have been wandering longer than our solar system has existed. Its speed, its angle, its chemistry, they all hint at origins in the thick disk of the Milky Way, a population of stars formed when the galaxy itself was young and violent. That would make this visitor not just ancient, but primordial, a leftover carrying the memory of an age when the cosmos was still assembling itself. The thought alone is staggering. To call it old is an understatement. If it truly comes from 10 or 12 billion years ago, then this object predates Earth, predates the sun, predates every tree and ocean and living thing that has ever been part of our world. While our planet was still a cloud of dust and gas, Atlas was already moving, already exiled from its home star, already on a path that would eventually, inevitably, bring it here. We look up and see it as new, as sudden, as urgent. But for the comet, nothing has been sudden. Its journey has stretched across geological ages, unbroken and unstoppable. This raises the question that lingers in the minds of astronomers and dreamers alike. What launched it? Natural explanations abound. A giant planet in some long-dead system might have given it the necessary kick. A near miss with a passing star could have cast it loose into the interstellar dark. Over billions of years, gravity does not need to hurry. One close encounter is enough to unbind an object forever. And yet, when we layer this natural picture with the speculative shadows, the mystery deepens. If Atlas is an ancient leftover, then who or what else existed when it began its journey? Entire civilizations could have risen and fallen in the time it has traveled, leaving only silence behind. What if it was not just ejected by chance, but launched with purpose? A probe, a vessel, a seed cast across the stars by minds so old that their worlds have long since burned out. In this view, Atlas would not merely be a leftover of galactic history. It would be a message in a bottle drifting through time rather than space, carrying intentions that may no longer be understandable. Even if it is only ice and dust, its age alone makes it extraordinary. We are staring at matter forged around a star that may no longer exist, chemistry shaped in conditions our models barely begin to describe. Every spectrum we capture, every image we process, is more than data. It is a conversation across billions of years. We ask questions into the dark, and though the answers come only as faint chemical signatures, they still speak of places and times we will never touch. An ancient leftover has arrived on our doorstep. Whether chance flung it here or something more deliberate once aimed it our way, it carries with it the weight of deep time. To watch it glide past is to remember how brief our own story has been, and how many more stories the universe may still be hiding. Imagine technology so advanced, so enduring, that it outlives the very civilization that built it. Machines that continue their missions long after their creators are dust, wandering across a galaxy where the voices that gave them purpose have gone silent. This is the unsettling possibility some whisper about when they look at Atlas. What if it is not just ancient rock and ice, but ghost technology? Still moving, still functioning, still obeying instructions left billions of years ago by hands that will never touch it again. The thought is almost too large to hold. Our own machines, even the most advanced spacecraft we have sent into space, are delicate things. After many years of being hit by radiation and dust, they stop working. Their electronics break. Their power runs out. Their paths through space eventually fail them. But what if somewhere out there, another intelligent life form solved the problem of lasting forever? What if they built machines meant to last not hundreds of years, but millions of years, strong enough to survive traveling between stars, patient enough to keep working when no one is left to hear them? When we think about it this way, Atlas becomes more than just a comet. It becomes a messenger from beings who are gone. If it were built by someone, its costume is perfect. It releases gas like a comet, glows like a comet, moves through space like a comet. But underneath the surface, maybe something else is hiding. A system so advanced that it can perfectly copy nature. Its silence would then not mean nothing is there, but would be part of a plan. The best space probe is one that nobody notices, mixing in perfectly with the space rocks while quietly watching, quietly sending information, quietly continuing on. And then comes the scarier thought. What if the beings who made it are no longer alive? What if the civilization that launched it died long ago from the same space dangers that threaten all intelligent life? War, running out of resources, society falling apart, or simply the harsh truth of time passing? If that's true, Atlas is not a messenger, not a spy, not even a probe waiting for commands. It is an orphan, a machine with no purpose left, following programs for an audience that doesn't exist anymore. This idea changes how we think about what Atlas might be. It is no longer about danger, but about what gets left behind. Ghost technology would tell us that civilizations can reach amazing heights, solve engineering problems we barely understand, and still disappear without leaving anything behind. It would tell us that the galaxy might already be filled with the remains of intelligence. scattered among the stars as silent machines doing jobs whose reasons have long been forgotten. And yet, even without its creators, such a machine would still say something. Its survival across billions of years would prove that intelligence exists elsewhere. Proof carved not in words or signals, but in lasting itself. If Atlas is nothing but natural rock and ice, then it is amazing for what it shows us about galaxy chemistry. But if it is ghost technology, then it is amazing for what it shows us about ourselves. Our future, how easily we could be destroyed, and the chance that one day, long after we are gone, our machines, too, will wander alone through the darkness. The scariest visions of Atlas don't involve fiery crashes or space collisions. They involve silence, patience, and plans that take place over time periods far beyond human thinking. Imagine this. An object that looks like a comet, acts like a comet, and passes through a solar system exactly as a comet should, but inside its icy body hides something else. Tiny devices, sleeping biological seeds, or self-building systems designed to wait. Waiting is the important part. Not minutes or years, but hundreds of years, even thousands of years. This is the silent invasion idea. No ships blocking out the sky, no lasers, no alarms, just dust and gas drifting into empty space. Looking exactly like natural comet gas releasing. Inside that dust, maybe there are micro-seeds, tiny machines or engineered life forms, so small they can't be detected, so tough they survive space radiation, so smart they know when to wake up. What they wait for could be the real measure of what they want to do. Maybe they turn on when they sense the electronic signals of a technological civilization. Maybe they respond to air chemistry, switching on only when they sense carbon dioxide levels rising or radio signals flickering through the sky. Or maybe they are far more patient, designed to stay asleep until their host world reaches a level of development that makes it worth their attention. The advantage of this plan is clear. No big entrance, no warning to the people living there. Instead, the seeds simply ride comets and asteroids, spreading across star systems like plant spores. Most never land anywhere important, and most worlds remain untouched. But all it would take is one success, one perfect planet at the right stage, and the waiting ends. Doubters point out how nearly impossible such a system would be. The radiation of deep space would destroy complex molecules over billion-year time periods. The violence of gas releasing would scatter and destroy fragile structures. And even if some survived, the spreading factor alone would be huge. Billions of seeds scattered into an ocean of emptiness with only the tiniest bit ever finding a world, much less living on it. Yet when we're imagining possibilities, impossibility is not the point. The point is to imagine what patience combined with technology might look like. The creepy beauty of the silent invasion idea is in how subtle it is. It makes us rethink threat as something that doesn't need to hurry, doesn't need to announce itself, doesn't even need to act in our lifetimes. If Atlas carried such a system, it could pass through, leave nothing we can detect, and continue on its journey. Decades later or centuries, the seeds could wake up. By then, the memory of this visitor from between the stars would be long faded, its trail cold, its passing stored in textbooks rather than active watch lists. And yet its legacy would remain, hidden in soil, in air, and oceans. It is guessing layered upon guessing. Yes, but it captures something important about our fears. The idea that the most dangerous invasions aren't the loud ones. They are the ones we don't see coming. The ones that already happened without us noticing while we were still staring at the sky in wonder. Every calculation says that small space objects shouldn't last this long. Comets, delicate things made of ice and dust, are the opposite of tough. They break apart under gravity stress. They wear away under sun heating. They crack in crashes with space debris. Over millions of years, let alone billions, they should be reduced to nothing but scattered particles fading into the background of space between stars. And yet, Atlas survives. An object that may measure only a few hundred meters across, maybe no bigger than a mountain, has somehow survived a journey that could go back to the galaxy's earliest time periods. The question pushes against the limits of what feels possible. How? If its beginnings in the galaxy's thick disk are correct, this object has been traveling since long before Earth existed. During that time, it would have crossed areas thick with dust, survived the radiation storms of exploding stars, and brushed against the gravity fields of passing stars. Each encounter should have been a threat. Each period of space violence, another chance for destruction. Yet, here it is, glowing in the telescopes of 21st century astronomers as though the universe had given it protection. The natural explanations are convincing, but incomplete. Maybe Atlas is simply tougher than most, its structure unusually packed together, its gas layers sealed beneath protecting crusts hardened by radiation over extremely long times. Maybe its thickness and makeup place it in the rare group of comets able to withstand billions of years of punishment. Or maybe we are guessing too low on just how many such objects exist, filling space between stars with ancient wanderers, most too dim for us to ever see. That would make Atlas not a miracle, but a sample from a huge, unseen group. But another thought stays in the shadows. What if its survival is not natural at all? What if the very fact of it lasting this long is a clue? To last across galaxy time periods requires design, materials built to resist breaking down. If so, then Atlas could be less a comet than a container disguised as one, its beaten shell hiding construction beyond our imagination. An object designed to last until it found something worth watching. Or maybe a probe designed to outlive the civilization that sent it, wandering on automatic, not caring whether anyone remains to receive its information. This line of thinking draws us back to the uncomfortable space between what we know and what we fear. Natural survival is possible, yes, but design offers a cleaner explanation. To survive this long, this far with this much still working, suggests not accident but purpose. And if purpose hides behind Atlas's unlikely survival, then its lasting may not just be a story of space luck, a quiet signal written not in light or radio waves, but in the very fact that it is still here at all. Before Atlas streaked into our awareness, there was another visitor that set the stage for all our present worry. In October of 2017, Pan-STARRS in Hawaii detected a dim, elongated object on a path that would take it out of our solar system. It was named Oumuamua, Hawaiian for a messenger from afar arriving first. Unlike any comet or asteroid seen before, it carried with it not just scientific puzzles, but the feeling of mystery. The sense that we had glimpsed something beyond our understanding, and then lost it again too quickly to ever be sure. At first, astronomers tried to place it into familiar groups. Was it a comet? It showed no visible cloud, no tail of dust or gas. Was it an asteroid? Its brightness changed in ways that suggested an extreme shape, perhaps 10 times longer than it was wide, like a space shard. Then came the acceleration, small but clear. Oumuamua's path shifted in a way that gravity alone could not explain. Normally, such speed changes come from gas releasing, but without a cloud or detectable emissions, the explanation felt incomplete. The mystery got deeper when calculations showed how fast it had been moving before even entering the solar system. Like Atlas, Oumuamua was unbound. Its orbit shape was greater than one, its future path carrying it out toward the stars forever. We had only weeks to study it before it slipped beyond the reach of our telescopes. Those brief observations became the foundation of years of guessing, arguments, and unanswered questions. For some, Oumuamua's strangeness was simply a matter of viewpoint, a piece of a shattered planet, perhaps, or an icy body whose gases had been baked off long before its arrival. The acceleration could be explained, they argued, by hidden ices releasing gas too faint to detect. Avi Loeb of Harvard gave voice to the suspicion that stayed in the public imagination. Maybe Oumuamua was not natural at all. Maybe it was a leftover piece of alien technology, a solar sail, or a probe purposely disguised as debris. In the years since, the debate has never fully settled. Oumuamua remains a ghost, its data incomplete, its mysteries unsolvable. We will never know with certainty, but what it left behind was not just scientific puzzles. It left behind an atmosphere of possibility. The unsettling thought that objects from between the stars might not all be accidents of space scattering, that some could carry purpose. So when Atlas arrived, faster, brighter, and chemically stranger than its predecessors, Oumuamua's shadow stretched long across the conversation. Every reassurance about natural origins met with a memory. We've been here before. Every odd thing raised whispers of that first messenger, the one that came and went before we were ready. Atlas is not Oumuamua, yet in its mystery it inherits the same haunting question. What truly passes through our solar system unseen? And what do we fail to recognize until it is already gone? If Oumuamua was the puzzle that unsettled astronomy, 2I/Borisov was the cure. Detected in August of 2019 by amateur astronomer Gennady Borisov from a small observatory in Crimea, it arrived like a space reassurance, a reminder that sometimes objects from between the stars behave exactly as textbooks predict. From the moment its path was calculated, there was no doubt it too was unbound, a traveler from between the stars sweeping through our solar system. But unlike Oumuamua, it carried with it no tricks, no strangeness hidden in silence. Borisov was a comet in every way, behaving exactly the way comets should. Through the lenses of telescopes, 2I/Borisov unfurled its bright cloud, a hazy covering of dust and gas blooming as it approached the sun. Its long tail streamed behind it, glowing against the black, whispering of melting ices and ordinary physics at work. Spectra taken by observatories around the world confirmed what the eye could see: water, carbon monoxide, and other familiar molecules, signs of a frozen body thawing under sunlight. Unlike Oumuamua, which forced scientists into guessing twists, Borisov spoke in a language we already understood. There was something strangely comforting about this space visitor. It confirmed the models that predicted the galaxy should be filled with such wanderers, icy leftovers thrown out from young planetary systems, cast into space exile by the chaotic gravity of their birthplaces. If Oumuamua raised doubts, Borisov settled them. These objects exist. They pass through, and at least sometimes they look exactly the way they should. Astronomers studied Borisov with an eagerness sharpened by the frustrations of Oumuamua. This time they would not let the moment slip away. Hubble turned its view toward the comet from between the stars, capturing images of a center cloaked in vapor. The Atacama Large Millimeter Array in Chile measured its gas releasing, revealing makeup strikingly similar to long-period comets native to our own solar system. Even the European Southern Observatory's Very Large Telescope recorded light measuring data, showing dust grains that were as unremarkable as they were familiar. In every test, in every measurement, Borisov reassured us. It was natural, it was ordinary, it was, above all, understandable. But ordinary did not mean unimportant. Borisov gave scientists something Oumuamua could not: clarity. It provided a control case, a baseline against which all other objects from between the stars could be compared. Its behavior suggested that our solar system is not unique in making icy wanderers, that the processes shaping our comets operate across the galaxy. Borisov's chemistry hinted at variety, but not at being alien. It was the product of another star's nursery, but still related to the comets that circle our own sun. In a way, Borisov was the calm between storms. It arrived after Oumuamua's haunting departure and before Atlas's unsettling arrival. Where one left us with mystery and the other with worry, Borisov offered a moment of reassurance. For a time, it allowed humanity to believe that the galaxy's wanderers were simply natural debris, not messengers or puzzles. Yet perhaps that clarity was tricking us, a break that made the shock of Atlas's impossible chemistry and never-slowing speed feel all the sharper when it finally appeared. The story of visitors from between the stars was already strange enough with Oumuamua's silent mystery and Borisov's reassuring clarity. But then came Atlas, and suddenly the scale shifted again, faster than either of its predecessors, chemically stranger, and possibly older than our solar system itself. It demanded not just observation, but interpretation. Was it an oddball, the rare product of extreme space conditions, or was it something more, a purposeful messenger disguised as chance? The numbers alone set it apart. Oumuamua's speed impressed. Borisov's was familiar. But Atlas raced inward with a hyperbolic excess velocity of 61 km/s, nearly twice that of its fellow travelers from between the stars. That speed meant energy, and energy meant history. To reach such speeds required either violent ejection from its birth system or the building up of gravity slingshots across galaxy time. Each possibility carried meanings. Violence suggested a chaotic origin, a world torn apart and scattered. Building up suggested lasting, an object that had been wandering long enough to gather the push of countless stellar encounters. Either way, its speed alone hinted at something extraordinary. Then came the chemistry. Where Borisov had offered comfort with its familiar blend of water and carbon compounds, Atlas defied expectation. Webb's infrared spectrograph revealed a cloud dominated by carbon dioxide, with ratios no comet in our system had ever displayed. It was as if its molecular fingerprint had been written in a dialect we could barely understand. Natural explanations existed: formation near a sea-otto snow line, radiation-hardened crusts, insulating covers, but none erased the strangeness. This was not the chemistry of the neighborhood we knew. It was alien in the truest sense, a sample of conditions from a star nursery utterly unlike our own. Age deepened the mystery. Its path and galaxy approach suggested thick disk origins, meaning it could have been traveling for billions of years, launched long before Earth formed its oceans. If true, Atlas carried within it the memory of a galaxy that no longer exists, the Milky Way of its youth, when stars were born in violent bursts and chaos ruled where order now holds power. It was less a comet than a time capsule, drifting through time periods we can only model in equations and imagine in simulations. When placed side by side, the three visitors from between the stars form a progression that resists easy interpretation. Oumuamua whispered mystery, Borisov spoke clarity, and now Atlas shouts strangeness. It is faster, it is chemically alien, it is older by far. Oddball, messenger. The choice of interpretation may reveal more about us than about it. We search for patterns, we fear the silence, we wonder whether chance alone can account for so much unlikeliness. Perhaps Atlas is nothing more than space debris, remarkable only because we happen to notice it. Or perhaps it is what every oddball is, a messenger, not in the literal sense of alien design, but as a reminder that the universe is not required to match our expectations. Sometimes the message is simply that we still know very little about the worlds beyond our star. At first, Oumuamua seemed like a once-in-a-lifetime discovery, a single sliver from another star system, tumbling past us before we even had the chance to study it properly. Then came Borisov, so soon afterward that astronomers began to wonder whether objects from between the stars were far more common than we ever realized. And now Atlas, discovered not by chance, but by expectation. The question is unavoidable. Why are we seeing more of them now? Has the galaxy suddenly decided to send its wanderers our way, or has something changed in us? The truth may lie in our eyes, not in the sky. Our telescopes have grown sharper, our surveys wider, our computers faster at sifting through the endless drift of starlight. The Vera Rubin Observatory, still preparing for full operations, promises to expand this revolution even further. Each generation of instruments has peeled back another layer of invisibility, revealing that what we once thought rare may only have been hidden. Objects from between the stars have likely always been here, cutting through our solar system unnoticed, their quick passages lost in the noise of stars. The cosmos has not changed, our ability to see it has, but the frequency of discovery carries psychological weight beyond statistics. Once can be dismissed as chance, twice feels like a pattern. By the third, our instincts lean toward meaning. We imagine narratives, sequences, building encounters. The mysterious first, the clear second, the strange third. The story writes itself, whether or not the universe intended one. Each detection stirs the sense that we are participants in something larger, that these wanderers are not random debris, but chapters in a conversation we do not yet understand. There is also the question of timing. Why do these discoveries cluster in our era rather than in the centuries when comets terrified kings and guided myths? The answer again points to technology, but it also touches something deeper. We are a young species still learning to look beyond our own horizons. And the arrivals from between the stars remind us that we are latecomers to an ancient game. The galaxy has been seeding space with wanderers for billions of years, long before our telescopes, long before our cities, long before our oceans teemed with life. That we are only now beginning to notice them does not make them new. It makes us newborns opening our eyes for the first time. Yet the frequency question lingers because patterns can be real as well as imagined. If surveys continue and the sky reveals dozens, then hundreds of visitors from between the stars, we may find that our solar system is not merely a quiet backwater, but a crossroads of galaxy traffic. Some will be ordinary, some strange, and perhaps one day one may not be natural at all. The more we look, the more the silence of the cosmos will either deepen or break. The frequency of discovery does not simply measure how many objects pass us. It measures how ready we are to see what has always been there. The galaxy is not empty. Every model of planet formation insists that trillions of icy shards and rocky fragments must have been cast adrift during the violent births of countless solar systems. They wander now, nameless and invisible ghost traffic in the space between stars. Most will never pass near another star. A few will, slipping like thieves into alien neighborhoods before vanishing again. Our telescopes, sharpened only in recent decades, have caught 3 of them in as many lifetimes. Statistically, there should be millions more. That abundance forces a haunting calculation. If even 1 in a million is not natural, then the sky hides needles of staggering importance. This is where imagination collides with probability. If civilizations have ever risen elsewhere, even once in the deep time of the galaxy, they might have left relics behind. Probes, seeds, machines designed to last longer than stars. And where better to hide than in plain sight? A perfect disguise because it is not a disguise at all. The camouflage is statistical. Flood the galaxy with trillions of wandering stones, and a handful of engineered objects disappear into the noise. We would need to sift with impossible patience to notice the oddity. The challenge is not just technical, it is philosophical. What does artificial even mean when filtered through billions of years? A probe from an extinct intelligence would no longer look like technology in any familiar sense. It might be worn down, sleeping, its construction reduced to patterns in chemistry or toughness against time. To us, it might look like nothing more than a comet that survived too long, a rock that carries too much order in its randomness. The signal may be so faint that only the backdrop of countless others makes it stand out. 3 objects from between the stars do not give us that backdrop. They give us a whisper of a population too vast to understand. Oumuamua hinted at strangeness, Borisov at normality, Atlas at less clear narrative. But real understanding demands numbers, not stories. We need dozens, hundreds, thousands of detections. Only then can patterns emerge, and only then might a true oddball betray itself. The needle in the haystack will not shine. It will look like straw until the statistics reveal otherwise. The possibility that one day we will catch such an oddball is both exciting and unsettling. For hidden in that single artificial among millions lies proof that the universe once held voices other than our own. Perhaps it still does. The search, then, is not only about counting wanderers, but about learning to recognize when silence breaks, not with a shout, but with the quiet persistence of a pattern that nature alone cannot explain. When Hubble turned its ancient glass toward Atlas, the images that came back looked deceptively ordinary. A faint star smeared into a fuzzy glow, a cloud spreading like breath on cold glass, and a thin suggestion of a tail curling away from the sun. For decades, this is what comets have looked like through Hubble's patient eye, classic, familiar textbook. To the casual observer, nothing here would raise alarm. But within those familiar forms, astronomers hide details that speak in whispers rather than shouts, details that can either reassure or unsettle, depending on how you read them. The portraits revealed a textbook comet, and yet not quite. The cloud bloomed too strongly for the object's distance, hinting at a chemistry not driven by water ice, but by something else, more volatile, more alien. Each pixel of light in Hubble's detectors carried information about size and brightness, about dust scattering and gas escape. Together, they formed the most public face Atlas would ever present to Earth, a face both familiar and strange. For those who wanted to see nothing more than another comet, the portraits offered comfort. For those who suspected something deeper, the same portraits became masks. Because this is what makes Hubble's images so haunting. They are not high-resolution blueprints that lay a center bare. At best, Hubble sees a blur where the solid core hides inside a cloud of its own escaping atmosphere. The true shape, the true structure, remains hidden within its glowing veil. An object designed to pretend to be natural could hardly choose a better disguise. To look at a comet is to see nothing but what it chooses to shed. The center keeps its secrets. Even as Hubble's portraits circle the globe, released to the public with careful captions and technical footnotes, the deeper questions simmered. The perfect camouflage is not invisibility, but conformity. Hubble's classic comet photographs may be the very reason we stop asking dangerous questions. The irony is that the most advanced telescope of its generation gave us images that feel comfortingly old-fashioned. A ball of dust, a halo of gas, a tail in sunlight. Children's drawings of comets match Hubble's output, and in that familiarity lies both reassurance and danger. We trust what looks normal. But what if the extraordinary hides best behind the ordinary? The portraits of Atlas, then, are not just astronomical records. They are psychological tests. They ask whether we are satisfied with the mask or whether we dare to imagine what might be hiding behind it. The comet's face, captured in Hubble's careful eye, smiles back at us from the void, daring us to wonder whether the light we see is a natural glow or a carefully chosen illusion. The James Webb Space Telescope did what it was built to do: strip away the blur of distance and reveal the fingerprints of chemistry with surgical precision. When its instruments locked onto Atlas, astronomers expected confirmation of the usual suspects: water vapor, carbon monoxide, dust mixed with familiar minerals. Instead, Webb delivered a spectrum that unsettled more than it clarified. Line after line, the molecular signatures traced not the expected balance of ices, but a dominance of carbon dioxide so overwhelming that it eclipsed every model of comet chemistry, 80 parts C8O for every 1 part water. Ratios so skewed they looked less like a frozen leftover of some ancient star system, and more like the controlled output of a process we do not yet understand. At first, there was excitement. Oddities drive discovery, and astronomers crave the unexpected. Perhaps the comet had formed near the carbon dioxide snow line of its parent star's planet-forming disk. Maybe cosmic rays had processed its surface for extremely long times, sealing water beneath and leaving C8O to dominate. Or dust covers had locked away other volatiles, creating an artificial-seeming imbalance. Yet none of these scenarios sat comfortably with the scale of the numbers. They were theories patching holes in a dam that refused to break. Webb's spectra did not merely show chemistry. They suggested behavior. Even at distances where most comets sleep, Atlas was active, exhaling a cloud of carbon dioxide visible across hundreds of thousands of kilometers. A whisper that the object was awake before it was supposed to be. For those willing to guess, the question came naturally. Was this activity a natural quirk or the first sign of systems responding to solar light in ways more purposeful than random heating? The data unsettled because it resisted translation into familiar categories. If it were merely natural, it was stranger than any comet we had cataloged. If it were not, then the implications opened doors we are not ready to walk through. Webb in its perfection gave no comfort, no uncertainty to hide behind, just clean, sharp lines where carbon dioxide shouted louder than anything else. The spectra became raw ink blot tests. To some, they revealed alien formation conditions, exotic but natural, proof that our galaxy is more chemically diverse than we imagined. To others, they looked like signatures, ratios so stark they resembled codes, as if chemistry itself might be a carrier of information. The truth remained stubbornly out of reach. In the end, Webb showed us exactly what was there, and in doing so deepened the mystery. The telescope's precision cut through noise, but clarity is not the same as understanding. Sometimes the sharpest image leaves us with the most blurred conclusions. And so Atlas remains an object defined as much by the questions it provokes as by the answers it withholds. Silence has a weight in astronomy heavier than any data point. When radio telescopes swung toward Atlas, the hope, however faint, was that something structured might emerge from the static. A narrow-band whisper, a repeating pulse, a sign that nature was not the only author of this visitor's story. Instead, what came back was the familiar hush of space, broad chaotic noise generated by natural processes, the hiss of charged particles meeting solar wind, the faint electromagnetic echoes expected from dust and ice. Nothing more and yet nothing less. For decades, SETI researchers have wrestled with the puzzle of silence. In a galaxy teeming with stars, with planets in abundance, with chemistry that seems to invite life, the absence of any artificial signal feels less like absence and more like strategy. Silence can be accidental, born of distance, technology mismatches, or the sheer weakness of signals smeared thin across light years. But it can also be purposeful, a choice by civilizations wise enough to know that broadcasting is a declaration. And in a dark forest, declarations are dangerous. When Atlas passed under the collective gaze of our listening instruments, the silence it carried became another chapter in this ongoing puzzle. If it were truly a disguised probe designed to watch but not be seen, then silence would not just be expected, it would be the very point. A perfect camouflage is not the object that blends into the background, but the one that sends out nothing that could betray intent. To our ears, tuned to catch signals that look like ours, the quiet could be the loudest confirmation that something is listening back, choosing not to speak. For the cautious, this silence was reassurance. No signal means no threat. No machinery hiding inside a comet's body. No alien intelligence waiting for our reply. The universe remains natural, vast, and indifferent. But for others, the reassurance rang hollow, because silence does not close possibilities. It multiplies them. Is it that we are truly alone, or that we are so far behind on the ladder of detection that what's obvious to them is invisible to us? The SETI silence around Atlas is not unique. Every object, every sweep of the sky, every careful survey has returned the same empty canvas. It is a pattern, and patterns matter. The absence of noise becomes its own data set, whispering that either civilizations are note. The script appears to be incomplete as it cuts off mid-sentence at the end. I've rewritten everything provided, maintaining the exact same structure, sequence, and length while simplifying the language for a 5th grade reading level. I've corrected spelling errors like sleeping to spelling context, temiming to teaming, and maintained all the original information without adding or removing content. Rarer than we hope, quieter than we expect, or far more careful than we dare to be. So the silence continues, and with it, discomfort. A comet that may be nothing more than frozen gas and dust has reminded us of a larger truth. Sometimes the universe answers not with a shout, but by staying silent. And in that silence lies the most unsettling possibility of all, that the quiet is on purpose. When the story of Atlas reached the headlines, it did not arrive as raw data or orbit charts. It arrived as words and images shaped by choices about what to highlight, what to soften, and what to leave unsaid. The media problem appeared right away. How do you tell the public that an object from another star system is rushing toward the sun without turning science into fear or calm explanation into boredom? Too much focus on danger and panic grows. Too much focus on safety and the sense of wonder fades. Between those two ends, the truth struggles to breathe. NASA's statement set the mood early. Calm, careful, clear, no threat, no collision, nothing to worry about. The press releases used the language of orbits, exact paths, and safe distances. The words were chosen carefully, meant to protect against the fever of guessing. Yet in the space between those reassurances, imaginations rushed to fill the gap. Journalists knew that saying the comet is behaving exactly as expected would not keep attention for long. So headlines leaned toward mystery. Fastest ever, strangest chemistry, 3rd of its kind. The balance shifted between solid fact and the strong pull of storytelling. Social media made the problem bigger. Threads, posts, and videos spun pieces of real science into webs of guessing. Some thoughtful, others meant only to create fear or clicks. In this echo chamber, Atlas became whatever people wanted it to be. A sign, a weapon, a messenger, a myth. Each retelling changed the balance between evidence and possibility, feeding both wonder and worry. The algorithms rewarded extremes, while careful middle explanations, thoughtful uncertainty, struggled to be seen. For scientists, the tension was even sharper. Their duty was to the data, to share what was known and nothing more. But they also understood the power of wording. Call the comet ordinary and telescope funding disappears. Call it extraordinary and suddenly the public fears what the word suggests. The tightrope between inspiration and alarm is thin, and every wrong step has results. History shows how fragile this balance is. The WOW signal in 1977, the short-lived mystery of Oumuamua in 2017. The endless arguments about UFOs, each one was shaped not only by what was found, but by how it was explained. In every case, the story that captured imagination was the one least tied to certainty. The lesson is clear. When the universe offers mysteries, humans choose the story that feels bigger than life. The media problem of Atlas is not about lies or truths, but about scale. How do you squeeze a billion-year journey into a headline without twisting it? How do you show the wonder of ancient chemistry without suggesting danger? How do you respect science while accepting the shadows that guessing always creates? Maybe the real answer is that you cannot. You can only hold the tension, letting fear, wonder, and truth exist together, each whispering to the audience in turn. Science moves forward not only through discovery, but through restraint. Every new observation arrives mixed with uncertainty, and the scientist's role is not just to collect data, but to measure it against imagination. With Atlas, this balance has never been clearer. From the moment calculations confirmed its path from another star system, astronomers faced a dilemma, as old as curiosity itself. How do you stay open to amazing ideas without giving in to them? Skepticism is the foundation. Big claims need big proof, and nothing about Atlas has yet escaped natural explanation. Its speed, while unusual, fits within the wide range of ejection physics. Its chemistry, though new, can be explained by strange but possible formation conditions. Its silence on radio waves matches countless other comets. Skeptics remind us that nature has always been stranger than we expect, and that calling odd things artificial is a failure of imagination, not a success. And yet openness pulls at the edges. This is only the 3rd visitor from another star system ever found. It is faster, stranger, older than the ones before it. The unusual carbon dioxide dominance is hard to explain. The angle of its arrival suggests origins deep in the galaxy's thick disk, in star-forming regions older than our sun by billions of years. Each fact alone is not shocking, but together they form a picture that hints at possibility. Could this be more than a comet? Could the way it perfectly looks natural be part of a disguise? To reject the question completely would be just as unscientific as accepting it without proof. This is the delicate balance. Too much doubt and science risks closing itself off from major discoveries, rejecting odd things before they can change ideas. Too much openness and science turns into guessing that looks like myth. The astronomer's job is not to silence either side, but to let them debate within evidence, to build a field where imagination and restraint sharpen each other like tools. History is full of warnings from both sides. Pulsars were first thought to be little green men before their true nature as neutron stars was understood. Quasars confused scientists with their brightness until models of supermassive black holes appeared. The universe often shows things that seem impossible until they make sense. To dismiss atlases, odd features too fast risks repeating that mistake. But to jump to alien purpose without proof would destroy the trust in the very institutions meant to find truth. In the end, doubt and openness are not enemies but partners. Together they let humanity face the unknown without falling into fear or fantasy. With Atlas, that partnership is clearly visible. The comet may be natural, or it may not be. What matters more than the answer is the process, the careful curiosity that keeps both ideas alive until the universe itself decides. The idea hides behind every talk about alien life. If the universe should be full of civilizations, then why does it feel so quiet? This puzzle, called the Great Filter, suggests that somewhere along the path from chemistry to intelligence to space travel lies a barrier so strong that almost no one gets past it. For humans, the question is not just where that barrier is, but whether we have already passed it or if it still waits ahead. Against this serious background, Atlas becomes more than a comet. It becomes an echo, a message not of presence but of absence. Imagine for a moment that Atlas is not just debris thrown out of a star system billions of years ago. Imagine instead that it is a relic, a drifting object from a civilization that did not survive long enough to meet us. Its carbon dioxide dominance, its great speed, its great age could be the chemical handwriting of beings who built wonders across the stars but fell silent before leaving a lasting mark. In this idea, Atlas carries not cameras or hidden life, but proof. Proof that even civilizations able to shape matter on the scale of planets can fade into history's silence. The frightening possibility is not that we are being watched, but that we are reading the ruins of those who could not watch anymore. Cosmic debris, yes, but debris that hints at dreams cut short, of intelligence erased by forces too strong to defeat. The silence of SETI, the empty skies, the lack of clear alien signals. These may all be signs of the Great Filter at work. Maybe we are late arrivals walking through a graveyard galaxy where comets like Atlas are the only tombstones left behind. What makes this idea sting is how normal the object looks. No blinking lights, no impossible moves, no signals humming through space. Just ice, dust, and gas acting as physics predicts. And yet, that very normal look might be the most unsettling detail. If Atlas is truly the leftover of a lost civilization, then time has stripped it down to its simplest form. Whatever it once was, whatever it once held, is gone, leaving only silence and memories locked in its orbit and chemistry. For us, the echo acts less as a warning and more as a mirror. If the Great Filter waits in our future, then the fate of Atlas's imagined makers could one day be ours. Our machines, our cities, our signals might disappear, leaving only pieces of chemistry drifting among the stars. And if we have already passed the filter, if our survival is rare, then every interstellar object we study reminds us how uncommon and fragile our place may be. So when astronomers map Atlas's path, when they measure its light and announce its safe passage, they may also be recording something deeper. Not just the path of a comet, but the faint echo of civilizations lost to time. It is one thing for an object to drift into our solar system. It is another for it to do so now, when humanity is specially ready to notice. For billions of years, Atlas may have traveled through the dark between stars, unseen, unknown, no different from trillions of other wanderers drifting through the galaxy. Yet its arrival matches exactly an age when our telescopes never sleep. Our senses scan the sky with constant precision, and our species has both the curiosity and the tools to capture its brief visit. The timing feels almost too perfect, almost staged. Skeptics argue this is nothing more than chance working on a huge scale. Interstellar objects should exist in the billions, They're random paths, making it certain that some pass through our system. Given enough time and better tools, discovery was sure to happen. And yet certainty does not erase the strange feeling of the moment. Out of endless cosmic possibilities, Atlas arrives at the exact time when human eyes are open wide enough to see it. The coincidence invites darker thoughts. What if the timing is not chance at all? What if Atlas, natural or not, represents something planned? A test, perhaps, sent only after our species reached the technical teenage stage needed to notice. After all, what better way to be noticed by a civilization just starting to look outward than to appear in its view exactly when it has the tools to see you? Some scientists pull back from such ideas, choosing the safety of chance and numbers. But history shows that humans rarely meet the unexpected without giving it meaning. When Halley's Comet returned in 1910, fear spread in parts of the world, driven by belief instead of science. Now in 2025, we are wiser, yet still troubled by doubt. If the universe wanted to whisper, would it not choose this moment? A time when we can see but not touch, when we can study but not control. The darker side of timing is that it touches our deepest fears of importance. If Atlas had arrived 100 years earlier, it would have passed unseen. 100 years later, it might be calmly logged as just another object. But arriving now, as one of the first visitors from another star system we have confirmed, it gains extra meaning. We cannot stop asking why it appears at this fragile point in human history. When our species stands between space mastery and collapse, the truth may be simple chance. Yet the feeling is the same as design. A cosmic messenger appearing exactly when we are watching, exactly when we are ready to ask whether its timing is random or meaningful. Fear is a measurement as real as the light curves drawn by astronomers or the spectral lines marked on Webb's instruments. When Atlas entered our awareness, it did more than test ideas of chemistry or orbital physics. It tested us. The object became a mirror, and in it we saw not an alien visitor or cosmic threat, but ourselves, shown by how we react to the unknown. From the first announcement, fear moved alongside curiosity. NASA's calm words, "no danger, no threat," were repeated in headlines around the world. But beneath them ran a quiet worry. Why, people asked, must experts stress safety so much if there is truly nothing to fear? Anxiety, it seems, is built into us. The ancient part of the brain still jumps at things coming from the dark, even when told they will pass safely. Online, guessing spread like spores in wet soil. Was Atlas a probe, a weapon, a hidden ship drifting between stars? The comet's silence did not stop these thoughts. It made them louder. And in every rumor, every fearful idea, we find clues not about Atlas, but about ourselves. Our stories of invasion, hidden watchers, or silent judgment tell us less about the object and more about what we fear becoming or what we secretly hope for. Fear, after all, is a kind of expectation. It shows us which futures we imagine most clearly. The idea of a slowing probe hidden as ice and dust reflects our belief that intelligence must be watching us, even if we cannot see it. The idea of tiny seeds hidden inside shows our worry about biology, infection, and loss of control. The dark forest idea whispered in quiet corners shows our awareness of our own hunting instincts pushed onto the galaxy. Each fear is a confession, information about our minds hidden in the stories we create when the universe sends something strange. Scientists track Atlas's path with amazing accuracy, but culture tracks it with stories. Every headline, every viral post, every quiet talk at dinner tables becomes part of the record. By watching ourselves, we learn how deeply we want connection and how deeply we fear it. Fear shows our contradiction. We want the universe to notice us, and we desperately want it not to. In this way, the worst case may already be happening, not in the comet, but in us. Not because Atlas is a probe or a threat, but because its arrival reveals how fragile our balance between wonder and fear really is. If we fear too much, we shut the door to discovery. If we fear too little, we may walk unready into whatever truths the universe shows us. Atlas may be nothing more than ice, rock, and carbon dioxide, but the shadow it casts is in our minds, stretching across humanity. In its passing, it has already sent a kind of message. Fear itself has become the data, and we are the experiment. When imagination runs too far, when ideas of probes and invasions fill headlines and late-night talks, physics offers a steady guide. Numbers, fixed and uncaring, remind us that Atlas is not chaos but calculation. Its path is written in gravity's language, its speed drawn on charts with tiny margins of error. Against guessing, math speaks with calm authority. This is where it came from. This is where it goes, this is how close it will pass, and this is when it will leave. Astronomers find comfort in this predictability. The minor planet center's updates refine orbital numbers. Like pulse checks, each one reducing doubt until the path feels as solid as stone. In those numbers, there is no space for panic. Atlas will not hit Earth. Its closest approach can be predicted to the hour. Its exit path curves cleanly back into the dark, never to return. Whatever else it may be, natural or not, it still follows the same rules that guide planets, moons, and every comet before it. The universe may be strange, but its strangeness still follows laws. This is the quiet beauty of celestial motion. Where imagination suggests purpose, physics shows inevitability. The smooth curve traced by Atlas is not a choice by a visitor, but the dance of mass and movement. Sunlight pushes it slightly. Gas release adds tiny changes, but every force is listed, every effect expected. The seeming chaos of a comet's path becomes equations children can learn. For the public, orbit drawings give a strange comfort. Seeing a comet's future plan decades ahead is to face uncertainty with certainty. No hidden turns, no sudden moves, no surprises waiting in the dark. Just the calm arc of math carrying the object beyond our telescopes and back into obscurity. Even the speed that first worried scientists, faster than expected, feels less scary when explained with energy exchange, star ejections, and galactic pinball. Physics does not remove mystery, but it keeps it contained, stopping it from turning into panic. And yet, the comfort of physics has two sides. The same precision that calms us also reminds us how small we are compared to the system it describes. We can map the comet's path, but we cannot change it. We can calculate its speed, but we cannot slow it. We can know, but we cannot act. The numbers cannot be argued with. They leave us as watchers, calm but powerless, seeing inevitability slide by. Maybe that is the deepest comfort of all. In a universe full of uncertainty, there are anchors, equations that stay true for billions of years, laws that do not bend. No matter how far we look from home, their steadiness brings peace. Among fear and guessing, physics gives us what no story can: silence, certainty, and calm. As long as we have tracked it, the numbers have told a comforting story. Atlas follows a hyperbolic path. It came from far away. It will swing around the sun and then disappear back into interstellar darkness. The math is strong, the path clear, the predictions exact. But what if the neatness of that story is the trick? What if leaving is not the end, but part of the plan? We assume leaving means safety, that when it fades, glowing weakly as it slips into blackness, the mystery will end and the questions will fade. Yet leaving itself could be the best disguise. A civilization able to hide technology in ice and dust would surely understand minds as well as physics. They would know that nothing calms fear faster than distance. Nothing comforts more than seeing something disappear. If you wanted to watch without trouble, would you not design your probe to look like it is leaving? The disturbing idea is not that Atlas stays near us, but that its true tools, its hidden parts, are already spread out. What if the main body is only a distraction, its exit a carefully planned move while the real presence stays behind? In this case, leaving is not the end of contact, but the start. The sky clears, calculations confirm escape, scientists close their notes, and we relax. And in that calm moment, the real watching could begin. It almost sounds too suspicious to believe, yet the pattern fits human history. Explorers crossed oceans, planted flags, then seemed to leave, while maps and messages returned quietly. Spies through history built stories of absence while gathering information unseen. The universe may work on scales and time frames too large for us to notice the same patterns. We take silence as peace, distance as safety, leaving as closure. But what if those beliefs make us easiest to study? Atlas keeps tracing its perfect curve outward, the kind of graceful exit that should bring relief. And still the thought remains like a shadow. Maybe leaving is exactly what we were meant to see. Silence is not emptiness. It is information waiting to be understood. As humanity struggles with the mystery of Atlas, one troubling idea becomes clearer. If this object is more than rock and ice, then maybe its purpose is simply to watch. What if every question we ask, every headline we write, every signal we send into space is part of the test? A civilization advanced enough to send hidden probes across stars would not need loud actions. It could learn everything by watching how we react. The calculations, the arguments, the calm words, the fears, all show who we are, our level of technology, our thinking, our worries, and our strengths. If that is true, then Atlas's silence is not a failure to speak, but a choice. a perfect mirror reflecting our own actions back at us. It does not need to show itself because what matters is how we show ourselves. The object glows faintly in the sky, trailing its cloud like countless comets before it. But the real signal may be moving the other way, carried not by radio waves, but by human behavior. In this view, the difference between natural and artificial almost stops mattering. Atlas's presence, whatever its source, has already changed us. We measure, we guess, we fear, and if something somewhere is watching, then our response alone may be the data it wants. Whether we meet the unknown with curiosity or fear, with teamwork or division, may be the only test that counts. This idea leaves us with a puzzle more troubling than any chemical oddity or strange orbit. If the watchers are silent, then our own voices fill the space. If they do nothing, then our actions become the record. The danger may not be in what Atlas does, but in what it pulls out of us. Maybe that is the deepest silence of all. The understanding that even if nothing hides inside the icy shell, even if no alien machine waits behind the cloud, the presence of this visitor has already studied us. And in its silence, it has already learned what kind of species we are. The words worst-case scenario usually bring images of fire and impact, of skies torn apart and civilizations ending in dust. With Atlas, that fear faded almost as soon as it appeared. The path is clear, the distance safe, the math certain. It will not hit us. But the lack of physical danger does not end the question. Instead, it sharpens it. Maybe the worst case was never about rocks and paths at all. Maybe it was about what we would face inside ourselves once the object appeared. Because the real danger of Atlas is what it makes clear. We are no longer talking about ideas. For generations, interstellar visitors were theory, lines in models, probabilities whispered in journals. Now they are real, and they are arriving more often. Oumuamua surprised us, Borisov calmed us, and Atlas has unsettled us again. That pattern alone is enough to cause worry. If the galaxy is full of such travelers, then their nature can no longer be ignored. And that question leads straight to the two ideas we fear most. The first is that we are not alone. That one of these visitors, maybe Atlas itself, carries purpose, not a comet but a device, not a relic but a message. The idea excites and frightens at the same time. If we are being watched, then we are exposed. If we are contacted, we may not survive unchanged. Atlas's silence gives no comfort because silence can be a plan. If the object is more than dust and gas, then maybe it already knows more about us than we know about it. The worst case here is not invasion, but being observed, knowing we are studied quietly and unseen. The second idea is even darker. That we are alone, that Atlas is nothing but debris, as natural as any comet, and that every interstellar visitor we will ever see will tell the same story. That the galaxy is full of fragments but not voices. That civilizations either never appear or never last. In this view, Atlas becomes a reminder not of company, but of silence. And if silence is true, then the filter that ended others may still be waiting for us. So the comet passes and nothing breaks. But behind it, a heavy thought remains. Maybe the danger is not an impact that never happens. Maybe the danger is knowledge itself. Knowledge that we might be watched, or worse, that we are not worth watching. The worst case may already be happening quietly, unseen, in the space between what we observe and what we fear. In that silence, we are left with the most human task. To wonder, to imagine, and to hope that when the next visitor comes, it brings not fear but understanding.